Welcome to John Tyler Community College, ITN171. My name is Robert Konikoff, and I will be your instructor for this presentation. This presentation will review creating simple shell scripts. The objectives are simply stated as reviewing the lab requirements, using VI or VIM to create a shell script, walk through the building of the script, and capture the output in various forms, either to standard out or to a text file. The lab requirement is to build a set of executable commands in a single script. This will allow it to be repeatable, exportable, modifiable, and most importantly, make it quick and easy for us to repeat several commands so that we can do the same tasks over and over without human error. We will document the contents of the file, capture the output, and then place copies of the script and the designated output into designated storage locations for grading. First, we have to log into our server. Once we've logged into the server, then we can take a look and see what files are in our current home directory. Then we will build the file that we need, starting with a VIM or VI improved session. Notice that we are now in input mode or insert mode. VI has three modes: command, insert or edit, and extended mode. At this point, you should know that to enter the insert mode, simply press the lowercase I, and you will see insert appear in the bottom left-hand corner. When you are done inputting information, press the escape key to return to command mode. VI and VIM are very similar. The three modes are command, insert or edit mode, and extended using a colon, which allows us to use very complex commands. This lab will use the very basics of the visual editor VI or VIM, which is VI improved. First, we must establish the shell that we're going to use. When we log in to a Linux environment, there is a default shell that we are assigned upon login. Typically, it is a bash shell or born again shell. In order to specify a shell, you use the #bang. That #bang line allows us to map to a specific shell available within our system, and we can configure that shell to work within a specific type of environment, such as a K shell, a C shell, or a bash shell. We will use comments to document our script. The # tells the shell interpreter to ignore everything to the right. It normally will only execute commands up to the point where it sees a # unless the # has been what we call escaped. Shell ignores everything to the right of the pound. It is sometimes referred to as pound, hash, hashtag, or octothorpe. We will use comments in our script to group our commands and to provide detail for future reference. It's very important to be able to go back into a group of commands in a script and be able to understand why we did certain things certain ways. Don't confuse the # with the #bang sign. The ! String is used to identify in the first line of a script what shell environment will be used. The ! in traditional Unix and Linux is referred to as bang. There's a long history behind it. You can do your own research to determine why we call it a bang. Let me know if you decide a specific reason behind why it is called bang. Once we establish the shell environment for our script, then we will follow it with human information. Human information is that needed to identify who wrote the script, what it's for, when it was created, and any notes to do with the purpose or general organization. Many businesses will have a standardized header data set. For the purposes of our lab, we will specify the current name, current login name, class and section number, date and time you created or finished the project, and the project title, Config Lab. Make sure you use the Bash shell scripting environment. We will use the list of commands that we created in our previous lab. The current lab will automate the use of these commands. In this example, you will see a comment, project title config lab, followed by a comment, system identification, runtime, and current users. We execute the command date. There is an echo with a line. The echo statement returns to standard out a specific text string rather than the execution of any series of commands. We list the uname and the uname-a commands followed by another line, and the who-u and who-q followed by another line. This gives us the date, information about the system, and what current users are on the system at the time we run the script. Once we've completed writing the script, we have to actually exit the script. In this case, we put echo quote quote to put blank lines between our major information sets. Then we put a message stating end of line or end of the output file. Then we exit with a return code 0. Colon puts it into extended mode, W write, and Q quits. Once we have created and exited the file, then we must change permissions on the file. 740 will change the permissions to execute by the owner, readable by anyone in our group, but no one else will be able to review the file. So now we've got a script of all of our commands. What do we do with it? First, we have to ask this question: what is standard out? Typically, in a Linux system such as ours, standard out is the video output, redirected to the human. Systems without video monitors may actually redirect standard out to a file or to a printer. When we run the script without any supplemental commands or redirects, it goes straight to our video screen. However, we can pipe the results to other commands, such as less or more. Likewise, we can use a redirect symbol and send it to a text file. In order to run the file, note that we have to put a path reference in front of the file name so the system that we are in knows where the file to be executed can be found. // means in the current location, execute the file by name. So let's run our file, and you notice that it kicks everything through the screen too fast for us to read. So now we're going to pipe it to the less command. Less will allow us to scroll through one line at a time, multiple lines at a time, or a page at a time. Likewise, we can change it from pipe less to redirect to a specific output file. In this case, rwk2774 _config _data.txt. Now we have a text file that we can manipulate. We can change permissions on it, we can copy it, or we can move it from one location to another. Notice it has all of the required information for our server book. At this point, we simply copy it to our required locations for the lab, old work and home/students. That concludes the lab requirement. My name is Robert Konikoff with John Tyler Community College. Thank you.